Today our topic is limiting reagents. I know it's been a while, so just make sure that you have your note set. We're going to be doing the last page of that packet that you have. You also need a limiting reagent and percent yield worksheet that I gave you in class, and you will also need your calculator. You can have your periodic table out as well for the molar mass calculations. All right. So limiting reagent determination. These problems require a little more work because you have to decide which of the two starting chemicals to base your calculation on. One of the chemicals is going to run out first, so you have to use that to determine how you solve the problem. So the difference is going to be that you're going to have two reactants instead of just one. An example that I like to use when we're talking about this is sandwiches. If I want to make some sandwiches, I would need peanut butter, jelly, and bread. One of those things is considered the limiting reagent because it'll probably run out first. So I want to make these sandwiches. The thing that usually runs out is the bread. It doesn't matter how much peanut butter or jelly I have. If I only have one loaf of bread, then I can only make that many sandwiches. So there are two terms you have to be familiar with. One is the limiting reagent, and the other is the excess reagent, right here. The limiting reagent is the reactant that runs out first. Why? It limits the reaction. It stops it from going forward. The excess reagent is the other one, the one that didn't run out. All right, so those are the two terms we're going to use. So the first thing that we have here then is our calculation. So I've got an example here. I have copper chloride reacts with sodium nitrate to produce copper nitrate and sodium chloride. All right, so the first thing that I need to do is write that out and balance it. In order to balance that, I believe I need a 2 here and a 2 here, and I'm all set at that point. So if you have to, then pause that and make sure that you rewrite that equation. All right, I'm going to move forward, assuming that you paused it when you needed to. All right. So I go on to my question. It says if 15 grams of copper chloride reacts with 20 grams of sodium nitrate, then how much? So if I have 15 grams of copper chloride reacting with 20 grams of sodium nitrate, I need to figure out how much sodium chloride can be formed. How do I do that? Well, I'm giving two different reactants here. So the easiest way that I've found over the years to solve this is for you to just do stoichiometry twice. So when you get a limiting reagent problem, you're going to transfer both of them into the product. You're going to take the copper chloride and change that into sodium chloride. And then you're going to take the amount of sodium nitrate and change that into sodium chloride as well. All right. Now this may seem like you're doing twice as much work. Trust me, you're not. There's another way to solve these, and it's a little bit more complicated. This way, if I take my values, I take my two knowns, and I change them both into sodium chloride, from that information I can figure out which one is the amount of sodium chloride produced. All right. I'm going to ask you guys to change these to 0.0 at the end so that they both have 3 sig figs before we start. All right, so usually in class I have one side of the room do the first one, the other side of the room do the second one, so I'm just going to work through both of these here for you. Pause at any time. These are simply 3-step mass-to-mass problems. So you could pause now, try to figure them out on your own, and then check your work with my answer, or you can follow along as I do it, but you may have to pause at different times. All right, so the first thing that I have to do is using my flip chart. I'm going to have to figure out the molar mass of these. So I have copper chloride. The molar mass of that I got is 134.6 grams. for 1 mole of copper chloride. Now I'm going to do my mole ratio step using the numbers in the equation over here. Copper chloride has a 1 in front of it. Sodium chloride has a 2. So I'm going to go back over here. Copper chloride has a 1. Sodium chloride has a 2. Now I need to switch that into grams of sodium chloride. I know that molar mass is 58.5 grams per 1 mole. So I'm going to multiply that out. 15 times 1 divided by 34.6 times 2 divided by 1 times 58.5 divided by 1. And I got 13.0 grams. Now that may very well be the answer. I actually have a 50-50 shot right now of that being the answer. What I'm going to do is this problem one more time for the 20 grams of sodium nitrate. So again, all that's going to change here is that I need the molar mass of sodium nitrate. That is 23 plus 14 plus 3 times 16. That's 85 grams of sodium nitrate. Now I'm going to convert that. Sodium nitrate has a 2 in front of it. Sodium chloride has a 2 in front of it. I already figured out the mass of sodium chloride is 58.5 for 1 mole. Again, those are standard 3-step mass-to-mass problems that we have done. So I'm just going to now take that and multiply it out again. 20 divided by 85 times 2 divided by 2 times 58.5. And I get 13.8 grams. So looking at that, then I have to decide how much sodium chloride I can produce, because that was the question here. The question said, how much sodium chloride can be formed? Well, I don't know. I'm looking at both of these answers here, and I have to decide. And the easiest way to do this problem, then, is once you do the problem twice, whichever one gave you the smaller amount in the end is the answer, right? So the smaller answer, so that must be the most I can produce. I can't produce more than that. These two things are going to react until one of them runs out, right? By choosing this as the answer, that means this guy here, 15 grams of copper chloride, that was the limiting reagent. Okay, keep going here. What does it tell me about this guy? Well, since I didn't pick that problem as my answer, he must be the excess reagent. Okay? So there's our problem. We did our problem twice. We picked the smaller answer to tell how much sodium chloride can be produced, and then we determined from that which one must have been our limiting reagent and our excess reagent. So this question on the back then said, what is the limiting reagent for that reaction? So we would say it was the 15 grams of copper chloride. All right. The excess reagent was the other one. This question right here, it says, how much of the non-limiting or excess reagent was left over? This is often a question asked because sometimes we want to know what's going to be left over in this reaction once it goes to completion. I have a formula that goes along with this. All right. I call it the rep formula. I've never seen it before, but if you ever want to figure out how much of the excess is left over, you're really taking the starting mass of your excess minus some fraction of your excess that was used. So you can figure out that fraction by taking the small product over the big product. So we've already done this problem, so I don't want to reinvent the wheel and do anything else. I just want to use the data that I already have. So if I go back to my problem, I want to figure out how much of that excess reagent is left over. Well, my starting mass of the excess reagent was 20 grams. I'm going to take away some fraction of 20 grams. That's multiplying there. All right. Now that's not going to give me 0 here because you know from the order of operations you have to multiply and divide before you do this subtraction. So we're not going to get 0 here. All right. Our small product from the other side of this sheet was 13. Our big product from the other side was 13.8. Those are the two numbers that I want here, 13 and 13.8. Sorry. So if I now do that calculation as is on my calculator, 20 minus 20 times 13 divided by 13.8, that is going to tell me how much of my excess reagent is left over. And I got 1.16 grams. All right, 1.16 grams. That's probably the trickiest part of this, all right? The next question on here said, if 11.3 grams of sodium chloride are formed in the reaction, so I'm actually going to do this reaction with these two reactants, and I get 11.3 grams, so that's my actual yield. I got 11.3 grams. I want to know what's my percent yield. Well, this goes back old school to the beginning. Percent yield is the absolute value of my experimental, God, that's not actual, I'm sorry. That's experimental. Sorry. My experimental minus my accepted over my accepted times 100. Whoops. I just don't feel like starting over. So if I were to actually plug these in, though, my experimental value was 11.3. My accepted value, or what I should have gotten, was 13.0 over 13.0 times 100. All right? This is like parentheses. So I have 11.3 minus 13.0 equals 1.7 divided by 13.0 times 100 divided by 13 times 100. I get 13.1%. And that is my error, how far off I was from what I should have gotten when I got 11.3. All right, so let's set this aside. Then you can go back and pause, restart, whatever you need to do. And we're going to take a look at our worksheet here. All right, our worksheet already has a balanced equation on it, and it gives us two different amounts here. So question A says calcium hydroxide is used to neutralize acid spills. It reacts according to the following equation. All right. So it says, I've spilled 6.3 mole of HCl on the ground. I only happen to have 2.8 mole of CaOH2 on hand to neutralize it. I want to know if I have enough. Well, I don't know if I have enough. What I have to do is figure out what do I get here. Let's change it into calcium chloride. Right? This time I'm doing my problems in moles. Makes no difference. Mole is easier. I'm just going to do one step here. All right, so I'm going to change HCl into calcium chloride because that's one of my products. And I'm going to see how much of it I can produce. So let's go through this. So I need 1 mole of calcium chloride over 2 mole of HCl. 3.15 mole. Now I'm going to keep going here and do the next one. Change that also into calcium chloride. So I started with 2.8 mole of calcium hydroxide, and I'm going to do the same thing. 1 mole of calcium chloride. Calcium hydroxide also has a 1. So now I'm going to switch that. So I have 2.8 times 1 divided by 1. That gives me 2.8. Out of both of these, this is the smaller answer. So that means that that's how much calcium chloride I'm going to produce. So what is the limiting reagent? Well, if that's the smaller answer, then this guy is our limiting reagent. All right, so if that's the smaller answer, he is the limiting reagent in this problem. How many moles of the excess? This is where you got to do the rep formula. All right, this is where you have to do that rep formula. All right, to figure out how much is left over, I have to take the moles of my excess, 6.3, minus a fraction of 6.3. My fraction comes from these two numbers, 2.8 divided by 3.15. And I got 0.7. This time it's moles. Last time we did it, it was in grams. No big deal. This time it's moles. Alright, so that's how you do this. Now, if I don't tell you which one to change it into, like I just picked one, just pick one. Alright, in number 2, there's only one product, so you're switching them both into that. In number 3, there's 2 products, so no big deal, just pick one. Switch them into that to figure it out. So even right here I wrote convert to zinc oxide. On the back here, I don't tell you which, oh, I did in parentheses, sorry, I did tell you which one. So you're going to switch these to KCl. And in this last one, I did not tell you which one, but it says what mass of ZrCl4 can be produced. So you might as well switch it into ZrCl4 since I'm going to ask you about that in those problems anyway. Same thing with number 6. It says what mass of barium nitrate. So you might as well switch it into barium nitrate when you're doing the 2 problems. Alright, I hope those notes help. I know it was kind of quick and sudden that you guys had an off-campus day, but you're going to go back in the classroom and answer a question in there as well. So you have to complete this worksheet when you come in on Monday, and you have to have that question answered in the Google Classroom. Have a great weekend and enjoy prom.